Okay, then welcome everybody. I hope you can hear everything and see this wonderful screen of just posing to you the question we're going to be considering for the next hour and a half. We've come together to talk about and discuss the 2019 Henderson Colloquium. Since 1975, the British Group of International Association for British and Structural Engineering has held a 2-day colloquium in Cambridge every summer for about 25 invited participants. The purpose of the event is to exchange views on a structural engineering theme of topical importance. Each participant is invited to make a short presentation to trigger constructive discussions in a relaxed surroundings of Christ College, when we don't have a pandemic. It was online this year. Usually, a summary document is produced, but today we'd like to go a little bit further and share some of the presentations from 2019 with you. Rerunning all of the presentations would keep you here all night, but today we assemble 4 that fit together well, we think. Designers' stories, designers' practice, developing designers, and why there is a philosophical imperative. IABSE is a scientific and technical association comprising members in 100 countries and counting 56 national groups worldwide. The association deals with all aspects of structural engineering, with the term structures encompassing bridges, buildings, and all types of civil engineering structures composed of any structural material. The aim of the association is to exchange knowledge and to advance the practice of structural engineering worldwide in the service of the profession and the society. Normally, the subject chosen for the Henderson Colloquiums is quite specific. This can be technical or non-technical. It's been everything from highway loading, changes to structures in time, uses of appropriate technology. But this year, in 2019, inspired by a quote from Herbert Hoover, in 2019, the question of whether engineers could be an unending stream of goodness was posed to the 19 delegates. A question that at first I thought, and I think many others did, was a bit off the wall. But then when you dig deeper, the conversations that arise around this touch on issues that are at the core of what we as engineers aim to do. This webinar has been set up to share some of the ideas nurtured from the colloquium and discuss further with the wider industry, you all here today. To this end, please submit questions and or your thoughts throughout the webinar to start the discussion after the presentations. I emphasise we will have the discussion and questions after all 4 presentations are given. So firstly, I'll hand over to Martin Knight to present on stories in design. Martin is a leading UK architect specialising in design of bridges and transport infrastructure. He founded International Bridge Designers Knight Architects in 2006, and his award-winning practice has built over 50 bridges. He is a fellow of RIBA and IABSE and the Institution of Civil Engineers, and an honorary fellow of the IStructE. Over to you, Martin.
Natalie, thank you very much. I'll try and share my screen.
Yep, cool.
Can you all see that? So this is a discussion about the art of storytelling, which is central to the coming together of colleagues at the Henderson Colloquium. This is an annual event, a very enjoyable annual event, and it's a coming together of diverse minds to discuss aspects of bridge design and structural engineering. It's based upon storytelling, but perhaps we take that skill for granted. Storytelling is the oldest form of communication, an enjoyable art form as well as a system of knowledge transfer, and I believe it's more important now than ever. I know for experiences in New Zealand and elsewhere that in bridge design, a clear story animates a project and allows it to be understood by the widest audience. However, I'm worried that the tradition of storytelling is reducing in our everyday working lives as we focus on technical solutions and procedural systems instead of the people for whom we design. A strong design concept is the plot around which the design narrative extends and unfolds, and it remains present throughout the life of the project, from the origins of the concept itself through to the final opening ceremony, and for very much longer thereafter. At the Henderson Colloquium in 2019, as one of several presentations considering how engineering can be an unending stream of goodness, and perhaps why it more often fails to achieve that aim, I explored the art of storytelling as it applies to bridge designers, with the help of my favourite story, Zen and the Art of Motorcycle Maintenance. Written in 1974 by Robert Pirsig, this is a story of a motorcycle road trip, of a father and a son, of philosophy and reality. The road trip is a metaphor for life, and the experiences of the storyteller are used to explore themes of quality and a sense of place, which I believe are at the heart of an architectural storytelling of bridge design. The first narrative theme is quality, and the author describes a classical and a romantic understanding of the world, where the former sees the world primarily as underlying form, whereas the latter sees it primarily in terms of immediate appearance. It is tempting to correlate this with the differing understanding of engineers and architects in the world of bridge design, especially as these two understandings sometimes even fail to understand or even be aware of the other. And the issue with the romantic mode is that, as Pirsig goes on to say, feelings rather than facts predominate. Yet this is exactly how non-technical users of bridges and other infrastructure appreciate these projects. And conversely, the same users often cannot understand design in terms of the classical mode, where everything is carefully controlled and value is measured in terms of the skill with which this control is maintained. And that leads to fear, anxiety, and often opposition to progress. In reality, of course, these understandings are two sides of the same coin. And the best infrastructure projects now establish an architectural design vision at the outset to guide and communicate the wider benefits and setting out the role that design will play in bringing success, including towards net zero and through social value. The better we can communicate and understand each other's views, subjective as well as objective, the more likely the resulting design will succeed in terms of climate and social outcomes. The second narrative theme is a sense of place. Pirsig's tale is rich in description of the sense of place, of views and weather and noise and speed, and their effect upon emotions. This combination of appearance and experience are what my studio refers to as the view of and the view from, and it informs our thinking in bridge design, especially for pedestrians. Bridge design is a potent architectural example of the sense of place that human beings so frequently yearn for, and which is at the center of the philosophical analysis of being. Empathy is at the heart of storytelling, the ability to engage with an audience. I believe it is also a key skill for designers, and as bridge architects, our approach to design, regardless of scale or location, is to robustly ask questions in this specific order. First, why and who, and only then what and how. Meaning, why is this project necessary and who will it affect should be thoroughly understood before the best answers to what is the design solution and how is it built can be found. The first two questions are open, outward, creative and empathetic, and lead naturally to the latter two, which are increasingly reductive, inward, and focused on delivery. And this order obviously reflects the fact we are people designing for people. Both of Persick's themes are valuable because with good storytelling, the audience ultimately cares about design, identifies with the project narrative, and becomes engaged in a form of emotional and intellectual participation. This is important because there is significant public skepticism about the use of technical language to obscure the true nature of infrastructure proposals. This has been reinforced through a commitment-averse approach to planning on the part of major projects, which often lower quality as the promised design is developed and the balance between quality, cost, and time is realigned towards the latter two. Too great a focus on the classical mode, particularly the use of technical language, risks alienating the very audience we should be serving, and whose support is necessary to achieve the change in attitudes and lifestyles needed to address the climate emergency. Our experience is increasingly that investment in the romantic mode, in design and its broad communication from the early stage, pays back many times over in terms of cost and programme, because expectations between public and commissioning authority are aligned and risk is reduced. And this reduction in risk equates to reduction in cost, reduction in programme, and increase in value, whether environmental or social, and is an obvious area of opportunity for clients and designers alike. Of course, a good storyteller needs a good story, the characteristics of which are it is memorable, enduring, enjoyable, enlightening. This is equally true of bridge design, where the higher the design quality, the easier the story is to tell. And I don't necessarily mean iconic or landmark design, but rather the beautiful ordinary, which is just as thoughtful, but stands in quiet harmony with its surroundings. I hope the concept of architect versus engineer in bridge design is redundant, as too should be the focus on aesthetics as the architect's sole role. As long ago as the 1970s, Ove Arup wrote, "The distinctions between engineering and architecture are divisive and exaggerated," saying the architect should be part engineer and the engineer should be part architect in order to achieve a fruitful collaboration. And noting that a gathering of experts and specialists is, on its own, not enough to achieve design excellence. This will only be achieved by a team whose members collectively understand each other's methods, aims, and objectives. This itself requires respect and trust and empathy. With the pressing urgency of the climate and biodiversity emergency upon us, there is a need for a new paradigm which explores sustainable design in terms of why and who, which are the needs of the audience and the planet, rather than focusing too early on what and how. This change is as much the engineer's responsibility as the architect's, but is best addressed by both professions working closely together, harmoniously and collaboratively, but also thoughtfully and creatively. For infrastructure to best serve the needs of society, it must be widely understood and accepted. Fundamentally, this demands excellent design, teamed with positive stakeholder engagement, using communication which is accessible and inclusive, visual, written, and spoken. This is the importance of storytelling. Over to you, Natalie. Thank you.
Thank you very much for that, Martin. I think we can all understand where he's coming from. We all need a bit of a guide through your engineering, and the story that it goes with really does emphasise its purpose in a way. Our second speaker is Tim Lucas. He's a partner of Price and Myers and an associate professor at the Bartlett School of Architecture. He is an expert in design for digital fabrication and advocates minimal interface structural engineering. He's interested in both the nature of materials and the manner of how things are made and built, so that the fabric of the built environment can become more load-bearing and use up less material. I think we can all realise in this day and age that that's really important. So over to you, Tim.
Thank you, Natalie. Hi, everybody. Is this sharing? Yes. Great. Thanks for inviting us to this evening. This talk was over 2 years ago now, and I think, well, obviously a lot has changed in all of our lives and how we work and how we think. The title "Engineering in Action: Knowing and Not Knowing Yet" actually came from a book that I was reading that summer. It's not particularly accessible. Well, it was a book published in the 1980s, but I'll come back to that in a second. But the idea of not quite knowing when you start something, how you might finish it, and I think your comfort with that as an engineer is probably more. You're probably more familiar with that idea than perhaps someone who's a client or some building user would want you to be. So the idea of being less deterministic about how you might do something and having the braveness to start a design process without fully knowing the way out. And as you go along, not knowing yet and deliberately not having preconceived ideas about how you might build something really does allow you to deal with the emerging constraints that you discover along the way. And the idea of that as a process and the engineering not being fixed is something that was covered in this book that kind of I took the title from, but I fudged it from Science in Action to Engineering in Action. And I say this is a book that I sort of found, and we were spending summer of 2019 at Glastonbury, which was an amazing experience. Sort of we did a sculpture there and got a free ticket for the week as our fee, which was a pretty good deal, I thought. But so I was reading this in between all of the fun of Glastonbury, and the book is, as I say, it's published in '87, and it starts with a sort of story of actually the discovery of DNA, and also the story of someone in 1985. This book was published in '87, so in 1985, turning on a computer and the computer having a picture of DNA on its screen. And the idea that in 1985 the DNA is completely understood, but in 1951, when they were discovering it, Watson and Crick and Rosie Franklin and Maurice Wilkes and everyone else that was involved, the idea of that certainty emerging over time is sort of discussed in this book, and he talks about this in terms of a sort of two-headed god, Janus, and Janus sort of has two faces and says on one side things like get the facts straight, it's very determined. On the other side, get rid of all the useless facts. So maybe look at it from a different point of view. Maybe there's another system at play, and various other quotes. Just get the most efficient machine, decide on what efficiency should be. So on the left, thinking that there's an answer of how to do something, and on the right, thinking that answer may come through people working together and coming to a solution. Once the machine works, people will be convinced. The machine will work when the relevant people are convinced. So the more people, in the case of the DNA discovery, that came to that conclusion of it having a double helix, there were lots of theories about the structure, triple helix, a central shaft up the middle. The more people that came to that theory, the more credence that got, and then the more confidence people had to sort of get to the next step. So this sort of science in action is kind of well understood amongst people who study, how science works, and where you're discovering unknown things all the time. When things are true, they hold. When things hold, they start becoming true. So that I thought was very interesting as a way of thinking about how we do engineering and how we decide how to make and build things. And I'm aware that we're in a world where how we're supposed to do that is quite prescriptive, and we're given systems, especially in building construction, of different contractors doing different things, and concrete frames, steel frames, different solutions, and we're almost playing with those. So it made me think about two projects that I've designed in the last few years, about 8 or 9 years ago now. We started them. The first was a sculpture in Heathrow with Richard Wilson, and we started with this sentence: which is, imagine if this whole space was filled with clay, and then imagine that a stunt plane flew through it, spinning and cartwheeling to carve out a void through the clay, and then left that void was filled with metal. So the idea of this movement being solidified was what we started with, and we worked on this for 12,000 hours in my team over several years. And this is the form that we came up with, and it had a huge number of emerging constraints. And when we started, we really didn't know how we would finish. And this was an early 3D print of the shape, or a version of the shape. There were 49 latter iterations of this, so the shape changed and changed and changed. And the final piece is here. And if you go to Terminal 2, you can see how it's made. And when we started this process and we agreed our fee and we got going on the job, we really didn't know that 2 or 3 years later we'd have had 5 people in a sort of design factory in our office with guitar, all on CATIA licenses at sort of £1,500 a month just for the license rental. And we didn't know that we would have created this incredibly complicated timber framework that would hold the skin of the sculpture to sort of make Richard Wilson, the artist's idea, kind of come to life. And in doing that kind of idea of really fundamentally, how do you make something that is so complicated, no single part of it repeats ever? What is a process that can allow you to do that? And how do you design that process and make that emergent enough that we can deal with new constraints, like having to balance the thing on existing columns, or having to deal with a computer a control cutting machine that sets things on fire if it gets the wrong commands and stuff. So we kind of came through this process and really didn't treat anything as a given, other than the fact that we knew that we could use materials, and we knew that if we used timber, it would allow us to sort of separate things out into components and plywood ribs and plywood skins. And if we had some form of adaptable structure that we could change to the different situations along the sculpture, we sliced the thing up into many pieces and basically developed a whole system of construction, of programming, of fabrication techniques, of drawing or not drawing. We couldn't afford to draw 12,000 individual parts. So that process was very much not a black box. And what the book describes is the idea that some ideas become black boxes, in that you kind of don't really understand what goes into it, but you know what goes in and you know what comes out. So by opening that black box, you're sort of opening a design process into, in this case, how you make a very complex sculpture. And indeed, we kind of looked at other sort of ways of doing it, and indeed for sort of several years afterwards, I always sort of went back to, did we do the right thing? Is making 12,000 unique shaped pieces of plywood and steel and aluminium the right way to go? I was teaching with this guy who's called Yala Ferenga at the Bartlett, and he's an expert in hot wire and cold wire robotics. So should we and could we have made the whole thing with a robot? It all has ruled surfaces like our plywood structure did. I mean, this was built before Grenfell, and making things in polystyrene may not have been the right solution. So that idea of continually challenging yourself and those around you challenging and throwing in lob balls is very similar to that story of DNA being discovered. And at the same time, also in the story in the book, the idea that the computer that is turned on in 1985 showing the DNA was itself a very unblack box 2 years earlier, as they were trying to make the thing work. And this is before the current refinement we have in our computers that we just take for granted. So the other project was our home, actually, where I am now. This is my wife, and I'm sitting about 4 meters below her feet in our basement. And the process of how to build a house when you're a structural engineer was something that we got to explore, and we're very fortunate to have been able to do that, working with an architect called Piercy & Company. this is the sort of elevation of the house, and it's near Kew Gardens in Kew in southwest London, and it was very much built around making, and the idea was that we would build it from within. So the workshop you see in the basement was the factory that the interior of the house was built from, and one of the key drivers of the house was that it would be built around a courtyard, which would mean that you would need to build your house somewhere where you would need to assemble something and then lift it onto the edge of the site. So this kind of emergent thing, this was more of a solitary process because it was often just me and the architects working on this, and how you make large Corten steel, I should say that the house is made of Corten steel, and how you try and let go of that black box of how you build a building, and how you let go of, say, rain screen cladding and having a separate structure. And what I was very keen to do was to make the actual thing you see, the structure of the building, as well as the cladding, as well as the waterproofing. This is kind of easier said than done, and lots of how you fabricate something, how you weld something together on site, how you transport it, how you make it fit under bridges. Very kind of first principles engineering. And in what we wanted to do, we wanted to kind of have as few components as possible. So how could you design out a structure by having a structural skin rather than having the skin hanging off an internal frame? So this is it recently after completion, and we were sort of struck by this sort of it being a bit like a vehicle. So this is a Crossrail train being made in Derby, and our house being made in Hull, both made in the north of England. And how you as an engineer ought to really understand how something is made and built, and write down, in this case, to how many sheets of Corten do you really need, and can you use nesting software to actually use a few less sheets, knowing they cost £400 each, or if it's being built now, probably about £1,000 each. And that kind of process of construction, like the sculpture, being a fundamental part of how you conceive the whole project, and how you think about risk, and how you think about who you build it with, and as contractors, indeed how you install it on the site. So nothing was really very conventional, and it was fun. But in doing that, we kind of were aware that we would perhaps get a few things wrong, and generally we didn't get that much wrong. But when we and it was open, and lots of people visiting, and open house London this is. But what we discovered a little while later is that we'd sort of made a slight mistake on vapor barriers, and the acceptability. Well, in making that innovation choice, we definitely kind of didn't reckon on the fact that buildings are permeable from the outside in. These are 3D scans of the building that we did while we tried to work out what was going on. This was insulation that had been not really installed as well as it could have done. So we went through a process, and this was very alive in my mind when we were doing the original talk, because the work was happening kind of during the Henderson Colloquium. But a sort of second complete design process to actually build almost a structure within that outer shell made of plywood, which was then so thermally breaking. So next time, so understanding that structural facades mean that thermal breaks are extremely important. So this was really high in my mind, which is probably why I ended up talking about it at the event. But we used that process as a way to understand how to make and build something inside an existing structure. So we had the existing steel shell, it was 3D scanned, and then this internal plywood structure was then built in that completely digitally, without so actually taking a new process through the thing. So not knowing yet is fundamental to a good outcome, because it allows flexibility in the best approach to deal with emerging constraints. So that's certainly the case with the sculpture, I think, and with the house. I mean, that we did have to go back and do a bit, but we still have something that uses far less carbon than it would have done, because it doesn't have most of the steel frame. It sits in the skin, and perhaps being less deterministic about what we do and being more experimental, bringing others on that journey and seeing the engineer as part of the team who can persuade people and give confidence and assurance when the path ahead isn't completely clear. So that I think is a good thing that we can do. And as we sit in a climate emergency, which wasn't even 2 years ago words on our lips that much, and thinking about how we take apart that black box and be less deterministic about how we build things and actually look for more experimentation and how we can use less material and use it more efficiently and reuse existing structures and chop them up if we need to and reuse them in other things. We're now seeing this in the London plan, which requires us to use 95% of the building on site. So that's driving real innovation, but it's just forcing us to let go of those preconceived ways that we build things and actually open that black box and delve in. And I think that's very exciting for us as engineers going forward, and that we're sort of key drivers in that work. So I'll stop there. Thank you.
Perfect. Thank you very much, Tim. Thank you for that. It's a very interesting look at a different journey compared to Martin's story. We've got to explore where we're going, and I think it's very easy for us engineers to look at the end game all the time and be determined to get there the fastest, quickest way, and not explore around some of those ideas maybe.
Yeah.
So our next speaker, Margaret Cook, has been a director at Integral for nearly 20 years and is a conservation accredited engineer. Her work on old and listed buildings has led her to be a passionate advocate of reuse and as one of the primary means to tackle climate change. As a female engineer, having had her share of the benefits and challenges that brings, she has written and spoken about how and who we recruit into engineering and the advantages of a diverse workforce. So with that in mind, I will hand you over to Margaret as she goes through.
Thanks, Natalie. Hello, everyone. So yes, I when we did the Henderson in 2019, I was thinking about the recruitment process and about the skills that engineers need to have if they are to be a force for good. And really, it's taking on the theme that Tim has just finished on, thinking about how we express what we do. So I think there is something about the way that we select and train and encourage engineers, which means that we're quite bad at speaking up and being heard. So although we ought to be leaders in design teams and on sites and generally across the world of construction, too often we're not. We're pretty good at leading our own small teams, but we don't stick our heads above the parapet to become a force for good more generally. And there's nothing inherently wrong with being quiet, with being really, really good at your job and getting on with it diligently. But more widely across the profession, I would argue that we need to encourage ourselves and our colleagues to speak out more. We've got a lot to say, especially about sustainability. We have lots of knowledge and passion. And I think as engineers, we have inherent goodness because people don't come into engineering to make their fortunes. Most people choose engineering because it suits their skill set. But often because they recognise that it's a really practical way to change the world for the better. So if we want to be heard, what do we do? What do we do to improve that situation? And I would argue that it starts in school and that university entrance requirements pre-select a certain type of person. So we insist that engineers are excellent at maths, not just good, but really, really good. And university selection favours those who've got A's at A level in maths and further maths and physics, or similarly scientific subjects. And given the narrowness of our A-level system, that means that a typical undergraduate has not been trained in English or philosophy or debating skills or critical evaluation since they were 16 at best. So I think we need to make the same shift as a profession as medicine has done. So back in the olden days, when the dinosaurs were young and I was in the sixth form, medics were still chosen on the basis of having an incredible memory for unrelated facts, which they could regurgitate under exam conditions. And bedside manner wasn't even considered. Now the profession has moved on, and it understands that the way a patient is treated can be as powerful as the medicines, and that quite often the answer isn't a medicine at all, it's a different kind of a therapy. And that kind of understanding has led to a much greater emphasis in the interview process for young medics towards communication skills as well as academic ability. So going back to engineering, we tend to pick a group of people who are excellent at formal examinations, brilliant at understanding methods and principles. We're encouraged to believe that there's a right answer to any question. And through university, engineers have a full timetable of scientific skills. We do basic theory, we do material science, we do Eurocodes, we do calculations. On the bright side, the Joint Board of Moderators requirements now include a real emphasis on design and group working, and discussions of professional ethics and sustainability and the place of engineering in the wider world. And that's a huge advance, and it's so exciting to see that embedded in the curriculum as a requirement rather than as an added extra in the fourth year. Because I think we need to be encouraging the discussion of why in engineering rather than just the how. But I still think we're adding a veneer of professional ethics on top of a group of students who are essentially chosen because of their ability to pass an exam in further maths, rather than selecting people who are good enough at maths but have a real mission to use engineering skills for the greater good. So our poor undergraduate emerges from a world of exam passing certainty into the storm of real life. And early on in practice, I think we tend to reward the doers. So relatively low fees, relatively potentially high salary expectations, particularly now we've got student loans to pay back and things like that. They encourage us to reward our young engineers for getting their heads down and producing information. And so we perpetuate this mentality of engineers as calculators. And we tend to lose those who don't have an aptitude for straightforward production. So those who think there must be more to life move sideways, perhaps into project management, or they get out of construction altogether, worse still. And we absolutely need to learn our craft. There is no substitute for having designed lots of buildings, because it is by doing the calculations and the drawings that we gain our instinct for answers that look right. And that's what ultimately allows us to scheme design in a meeting or quickly know what is going to work. So I'm absolutely not suggesting that the apprenticeship stage isn't necessary or important any more than I'm suggesting that being good at maths is not a core requirement for being a good engineer. I'm simply saying that we should be encouraging a wider view in people throughout their undergraduate and early professional lives, and recruiting people into engineering who have an aptitude for a wider skill set. So as our graduates become more senior, we start to value a range of other skills, the ability to organise the work of other people, teamwork, a pleasant manner in meetings with design team members, clients. But essentially, again, we are taking a group of scientists, training them to sit quietly and produce the goods, and then giving them a veneer of soft skills on top of their natural wish to hide. So why does it matter? Is there anything inherently wrong with an engineer who quietly and consistently produces brilliant design solutions? Of course not. The world absolutely needs those people, but it also needs people who can speak up. And I think, most of us probably think we have more common sense in our little fingers than the average career politician. Yet our training doesn't encourage us to speak out, even about the things that we're really good at. So, embodied carbon in construction is a huge issue. And we are the ones with the means to design better and more efficiently, and to use, or better still reuse, materials which have less impact on the planet. And yet we don't often have the space to do those things. It's cheaper and quicker and less risky to design a big beam than to finally design a thing of beauty with attendant analysis, the careful checking, the sleepless nights. And we might be allowed to do it on a bridge or an iconic building, but the issue with carbon footprint lies in ordinary day-to-day buildings where we over-design to compensate for poor workmanship. We over-design because it's cheaper to make all the beams the same. We over-design because it's easier to construct that way. And we know we're doing it, and yet it seems almost impossible for us to say so. So we struggle to persuade clients that design is an investment and not a cost. Essentially, we struggle to be heard. And I think we are our own worst enemies. We don't like to boast. We're a humble profession by nature. We're trained to be accurate and rigorous. So we tend to hold back from saying what we believe, lest our facts and figures are not completely perfectly correct. So the solutions, I guess I question whether the mathematical training should be given such precedence when we select undergraduates. We certainly need mathematicians, but we also need people who are good enough at maths, but also have an understanding of history, of architecture, of debate, of presentation skills. And I'd suggest that the vast majority of day-to-day engineering, low-rise, new build, reuse projects don't actually require maths, which goes much beyond a decent A-level. So therefore, it seems inappropriate to push for huge amounts more at degree level. And for some people, obviously, it's necessary, it's joyful to take the next steps, you know, to do the kind of crazy mathematical projects that Tim was talking about earlier. But for most of us, so many other factors come into play: the ability to sketch, the ability to negotiate, to understand what our client or architect is trying to achieve and find an exciting solution, sometimes by building nothing at all, and to think properly and carefully about why we're building and whether it's right to do so. So I think as a profession, we need engineers who can speak, not just the big voices, not just the Ove Arups, the Sam Prices, the Chris Wises, but ordinary day by day advocacy for lean, high quality engineering. I think we've set our profession up to reward people who get on without question. But if we want engineering to be an unending stream of goodness, we can't keep doing that. We need to think more widely and more deeply about what we're doing, when we're doing it, why we're doing it. And we need to be able to attract people who understand that asking questions, challenging clients, exploring alternatives is as much part of their job as the technicalities. And that, of course, links back into Martin's thoughts on storytelling and on language. And hopefully by getting those voices heard, we start to reframe how our profession is viewed by the next generation and by the world in general. So back to you, Natalie.
Thank you very much, Margaret. You raised some really interesting questions that I can only wholeheartedly agree with. I know plenty of a brilliant mathematician who just can't get their words across, their ideas, concepts across. And then they become useless in a way. So we finally go to Nick Francis, who is the founding director of Imagine Engineering, director of Jury Training and Consultancy, and also teaches at the University of Sheffield. He spent 16 years as an officer in the Royal Engineers. He has been making him acutely aware of the impact and fragility of our built environment. He now focuses on the interplay between the technical engineering and human behaviours, helping industry and academia to respond to the climate crisis and the great acceleration of this. So over to you, Nick, to talk about a bit more of the behavioural side of us.
Great. Thanks very much. Well, hello, everybody. I can't see anyone, but I'm assuming there are people there and this isn't just some big practical joke. So I'm going to take inspiration from Martin and attempt to start with a story. So 20 years ago, I was an enthusiastic young army officer living out in Germany, and my soldiers would regularly get in trouble for drinking too much and fighting at the weekends. And one day, one of these soldiers came to me to ask if I could get the shop on camp to increase the cost of the beer. And I was like, what on earth are you talking about? And he told me, well, it's not my fault that I get in trouble every weekend. The beer's just too cheap. And besides, I'm just doing the same as everyone else. So clearly I told him, stop being an idiot, get out. You need to take responsibility for your actions, and then had a good laugh in the mess about that later. Now, we leap forward 20 years and we notice that our industry is rapidly trying to come to terms with its role in a global ecological and humanitarian disaster, but is seemingly incapable of doing anything about it. And we know the facts. I mean, we've got the climate stripes that I'm sure you're all aware of, with the various different scenarios, and even the very, very best scenario is pretty disastrous. We know our climate emissions have been rocketing for 200 years, and that's what we've said we need to do. So it looks pretty unlikely. We also know that our industry is responsible for about 40% of it. So we know that it's wrong. And various people, I mean, Rachel Skinner, the president of the ICE, is pointing this out to us. So there is leadership, but we know it's wrong, but it's just too cheap and easy to keep doing the same thing. And besides, everyone else is still doing it. So when I reflect on that conversation that I had with that soldier 20 years ago, maybe it was me that was the idiot for being so naive about human behavior. And possibly that soldier was actually onto something. So that leads us to a question. How do we do the right thing? How do we make that decision? And what is morality? Well, it turns out, as with all of these things, that very clever people have thought about this before. So introduce this character, Lawrence Kohlberg. So back in the 50s, he was a psychologist trying to work out what made people do what they do, what determines our moral behavior. And he came up with a thing that he called the levels of moral reasoning. And what he noticed was that doing the right thing is a decision. It's a cognitive process. And he studied this in apes and primates and children and adolescents and grown-ups. And what he identified was that there were a number of levels that you journey through as you grow up. And the lowest level is here, this pre-conventional level. So that is responding to punishment, first thing, and then you seek reward. And that is the level that my dog functions on. And that's the level that children operate on up to about 2 or 3. They will work out what gets reward, and that's what they get through. And then we move up to the conventional level. Now, this is the level that is driven by what is normal, what's normal behavior. So it might be, what are the direct consequences of my actions? What will people think of me? And then it progresses through to what would happen if everyone behaved like this, and actually enforcing the rules. And this is the stuff that teenagers grapple with all the time. What is normal? And you see the struggles of teenagers trying to figure out who they are and what they should do in their life. They're grappling with understanding what is normal. And then the final level is this post-conventional level. So you've got pre-conventional, conventional, and post-conventional. And post-conventional is what are the long-term consequences, what's actually ethically correct. And this is the basis for democracy, and this is the moral basis for what we do. Now, what Kohlberg found was that these pre-conventional rules, avoiding punishment and seeking reward, apply to everyone all the time. These conventional rules are what apply to most adolescents and most adults most of the time, just going along and doing what's normal. And very few people spend much time in this post-conventional level. Very few people spend much time there at all. So when we think about this model for moral reasoning, how does that relate to us in our industry as we're churning out pollution and we might be doing the wrong thing? Well, it turns out that about 200 years ago, we did this moral reasoning. If you go back 500 years ago, engineering mega projects were things like building castles, building cathedrals, building stately homes. They weren't for the greater good. That just wasn't what engineering did. But then with the Industrial Revolution, we had people like Thomas Treadgold, and his famous quote, it's the art, and I'm trying to read that backwards now, that's quite hard, the art of directing the great sources of power in nature for the use and convenience of man. So we've got this idea that engineering is somehow, the birth of civil engineering is somehow for the greater good, for the good of people. And we can see how that actually seeped into our industry. And what is our industry like now? Well, at this level, we've got the post-conventional reasoning, you know, the idea that civil engineering is taking nature's resources and using them for the betterment of people. But we've also got what's the normal behavior in our industry. Well, we've got institutions, we've got codes of conduct, we've got recognition for industry awards for people doing things well. And then also we've got in this pre-conventional level, the rules, the punishments. You know, if you don't comply with the codes, you get punished. If you build something that turns a profit, you will make money from it. So at a very basic level, we've got plenty of pre-conventional rules that are determining how we behave. So what does this actually look like? Well, let's go back a couple of 100 years. These are the sort of mega projects we had going on. So, you know, you've got big bridges, tunnels, sewage systems. So jump forward 200 years and we're basically doing the same thing because our moral framework is the same. We're using nature's resources, harnessing the forces of nature for the benefit of mankind. It's what we said we'd do, and we're still doing it. But that leads us to a problem, doesn't it? Because we know that that's what it looks like when we talk about our emissions. So maybe Dr. Seuss was onto something with the Lorax when he says, I have my rights, sir, and I'm telling you, I intend to go on doing just what I do. So that idea that we're biggering and biggering and biggering, and the evidence would suggest that that's exactly what's happening. We are making our infrastructure and everything is getting bigger and bigger and bigger and bigger. And we just can't really stop, which is a bit of a worry. So that can lead to the next question of how have we responded in a crisis before as engineers? What have engineers done in a crisis before? Well, we can pick out things like the D-Day landings and the Mulberry Harbours, you know, a huge engineering undertaking, completely successful. The Manhattan Project to develop the nuclear bomb, huge engineering undertaking that, you know, an incredible feat of engineering, whether it's good or bad is not the point. And then you can also think of the Apollo mission. So here you go, a space rocket with all engineers on the call probably. So we'll stick a space rocket in. Everyone loves space rockets. So again, the Apollo missions and engineers can do this. They can respond to change. We've done it before. But the thing with all of these examples is that if we go back to our moral case, if we think of, you know, the Apollo missions or the D-Day landings, the post-conventional level, the moral basis for it is very clear. Everyone knows this is something we must do. The conventional level, what's everyone doing? Well, everyone's pulling in the same direction. And the pre-conventional level, the reward or the punishment, well, the reward is there. We want to get to the moon. But the punishment, the fear of failure is very, very real. So you can see that in all of those examples, all of these levels of moral reasoning are hitting engineering as a sector and driving it forward. So what are we doing about the climate crisis? Well, this is where we're getting it wrong, because we have, as an industry, got sucked into the teaching of Peter Drucker, the sort of management guru, and we're attached to metrics and maths, harking back to exactly the point Margaret was saying. We love maths, we love numbers, and this idea, if you can't measure it, you can't improve it, or you can't change it. If you can't measure it, you can't improve it. Now, this logic works if you're looking at something like a continuous improvement process. You know, you measure something, you change it, measure something, change it, measure something, change it. But that's not going to work in a crisis, because you can't just wait to measure something. And we're now in the paradoxical position with all our attempts to measure carbon that we seem to want to say we must exactly quantify how bad something is before we have permission to not do it, which seems a rather weird way of trying to deal with a crisis. So let's have a look at some examples of, you know, major changes that have happened before, not necessarily in engineering. Well, let's have a look at the example of slavery. Here you go. So I've got a slave boat there. You probably all recognize the image. So that post-conventional thinking, that highest level of moral reasoning, started in 1765, but it took about another 70 years before that post-conventional reasoning trickled through enough into norms of behavior that it was passed into law. So it takes a long time. And then to get down into that pre-conventional level, that real visceral disgust hardwired into us, well, you can look at the ongoing Black Lives Matter campaigns and wonder, well, have we really finished this argument, or is it still ongoing? And also look at construction safety. So construction safety statistics, here you go, that's since 1974, so since the introduction of the Health and Safety at Work Act. And if you think of that one, we've got various things happening. The post-conventional argument took a long time to be won. You know, for centuries, we let people get killed in the workplace. But gradually that became unacceptable. And then finally in 1974, slam, you've got the punishment. The punishment happens. You get punished if your company kills people. And that's when we saw the sudden massive changes, when you've got all of these levers happening at once. The moral argument has been won. It's normal. And there is reward and punishment for doing the right things. So what do we need to do in terms of the climate crisis? Well, let's have a look at this pyramid. Let's have a look at the pre-conventional level, where we can say, well, we need to make sure it is you get rewarded for doing the right thing and punished for doing the wrong thing. Finance drives pretty much everything, we know. So we need to tax carbon. We need to make it expensive to demolish. We need to make it expensive to get rid of waste. And we need to subsidize the greener options, subsidize reuse. And also we need to punish transgressors. Conventional level, in the middle, we need to make doing the right thing normal. And we're starting to do that. There are the awards. We praise people who do the right thing. And we're good at that. We're getting good at picking out examples of good practice. But where we're probably less comfortable is actually criticizing bad practice. You know, we don't like conflict and we don't like biting the hand that feeds us. So which of us is comfortable to point out the bad behavior, to make it right and normal to do the right thing? And then we get to this post-conventional level. Well, we saw that, you know, the ICE and Rachel Skinner's recent presidential addresses, very powerful about this is the direction we have to go. And the Institution of Structural Engineers as well, doing a brilliant job, I mean, particularly in their magazines of pushing this agenda. So some great work going on there. But let's go back to Thomas Treadgold, where he, you know, in his quote, the art of directing the great sources of power for the use and convenience of man. Well, in 2018, in New Civil Engineer, there was an article saying, well, we maybe need to update this. The art of working with the great sources of power in nature for the use and benefit of society. Okay, so that sounds a bit better. And I've spent months grappling with this, thinking, oh, is there something we can we word this a bit better? And, you know, we've all come up with stuff, but maybe crafting nature's resources to regenerate a thriving planet and secure human well-being. So it's all sort of trying to encompass this greater need to look after the planet that we depend upon. But actually, 200 years ago, civil engineering was invented because we realized that putting civil, you know, people at the heart of the reason for our existence was important. And I wonder if maybe we should question the even framing of it as civil engineering, because does that imply an exclusion of the planet and the ecosystems upon which we depend? So I wonder. But what does it mean for us today? What do we have to do? Well, I would suggest that number one, we need to stop ourselves getting distracted by measurement. Stop trying to find the correct number before we can decide on our morality and what is right and wrong. And then we need to look at this pyramid and realize that this pyramid of what are we rewarded and punished for and what is normal are going to drive all of our behaviors. Every decision we make in work or at home is being driven by these. So we need to notice that that's happening. And then the next thing we need to do is pull all of these levers at once. We need to do the hard thinking, define our morality. We need to make doing the right thing normal. and make it unacceptable to do the wrong thing. And we need to set the rules so that they align with our morality. Right, I will hand back to you, Natalie. Thank you.
Thank you very much, Nick, for that. It's always very interesting to hear about human behaviour and how on earth we all think about things and get through life and try and be grown up or not, as the case may be. So, thanks to all the presenters giving us very different views on what goodness is and how engineering fits within that. So we've had a few questions come in, but I would nudge everyone to, fly in those questions, keep them coming to us, and we'll try and answer them in this time and try and discuss some of the issues that are being raised. So one question we've got is, so Tim invented the plane story and then followed where it took him. Is there any guarantee that this will end up as suitable post-conventional, according to Nick?
Well, the post-conventional way we built the artwork was really based on making it with as few as possible things and adding what at the time we were calling digital craftsmanship into it, where we were trying to build something really complicated in a really simple way, by kind of putting that engineering design thought completely into the process of how it was slotted together. So the whole thing was sort of three-dimensional jigsaw puzzle, made of wood mostly, actually. So very little steel, but we didn't really follow any convention in doing that. We just absorbed it from first principles. I don't know how clearly that came across for the few slides that I showed, but that wasn't really, I mean, we did it in terms of that being the normal thing to do. It sort of was, because we thought about it as a roof, and we built timber roofs with the company that built the artwork before. So in a way, we kind of we kind of veneered it with that kind of, it's actually only a roof that's in the shape of a sculpture. But we kept on falling back into the sort of punishment and the reward thing. With, we got blamed for the CNC machine setting wood on fire and told it was all our drawings' fault. So it was so easy to sort of, get back to the sort of base instincts at the bottom of that triangle of moral reasoning, which kind of, in hindsight, was amazingly kind of primitive in a way, but it was just so easy for the people kind of responsible for building and for delivering it, the contract, especially the subcontractor who built it. It was really every night was me on the phone with the guy running it at their end, smoothing things out, working the process. So it's very easy for us to go back to base behaviour, I think, and I think Nick explained it extremely well.
Yeah, that makes complete sense. It really does. Yeah. So Margaret, we've got another question for you, and it's from Ian Firth, saying he totally agrees with you. We need more arts literate undergraduates, but that he's questioning that our universities are still welded to maths and science as the only essential entry requirements, in spite of a lot of effort having been made to change this in recent years. Universities seem reluctant and slow to change. So do you have any ideas about how to change that slow-moving process? Or anyone on the panel?
Yeah, I suppose, I mean, it's I'm going to come straight back to Martin's storytelling. You've got to tell the story, haven't you? And I suppose the thing about, the universities, some universities are brilliantly wedded to industry and to real life, and but an awful lot are less wedded to industry. I think, in my world, in the world of conservation, I sort of end up saying, today I did an adding up sum, and sometimes on a big day I do a timesing sum. And that is the kind of level of mathematics that's necessary when you've got a beam which, you know, it's WL squared over 8, and it's really, really simple equations, because fundamentally what you're really looking for is, has it got a knot right in the middle of it? Because if you haven't spotted that, it doesn't matter how much maths you do to it, it's not going to stand up. So you're looking for you're looking for observation, and you're looking for a really quite instinctive answer. And I mean, I'm sure that my maths at university was particularly badly taught, because it was taught by the maths department rather than by engineers. But it took me, so I'm going to get a little, so it took me 2 years to discover that a moment connection is one like that, and a pinned connection is one like that, because nobody ever just got a ruler and showed me what that was, and nobody ever drew the deflected diagram. So and they always described it in mathematical forms. So that sort of really quite basic instinct, and that sort of sense of, you know, frankly, if you can pitch a tent, you can be an engineer. Some of that stuff, I think, at university level is not well understood, because they tend to work in a world of the sort of, you know, the brilliant Chris Williams, absolutely impenetrable lectures, but amazing great court roof. You know, because they're working in that world, they see the maths as being absolutely vital. But actually, unless you're working in Tim's world, unless you're doing those very kind of, that very, very kind of crazy high-end sculptural kinds of engineering, you know, the vast majority of what the vast majority of us do day to day is really simple maths. And what's more important is, you know, do we understand what the client's doing? Do we need to do this at all? Are they putting the right building in the right place? Can we persuade them not to build at all? You know, actually, have they bought the right plot? And should they in fact have bought the plot down the road that's much more suited to what they want to do? So there's just more, that our role is much broader than, can you design this beam for me? But I think we need to talk to the universities about that reality of day-to-day engineering, because if the universities aren't seeing it, if that's not the piece of engineering that they're interested in, then they'll carry on selecting the people that they think we need.
Yeah.
I would add, I think that there is an opportunity for universities to diversify the courses or the interaction of courses that they offer. And those courses that have got interdisciplinary communication are really outstanding. You get to see a view into someone else's world, and that doesn't have to be another designer. It could be a client, it could be an operator, it could be some person whose work, whose world that your work touches. But I think the more we operate in silos, and this is true very much within the profession, but the profession is just an extension of education. The more we stay in those silos, the less likely we are to find our way towards really valuable solutions. And I think one of the things that in watching and listening to these presentations this evening, which I've really enjoyed, it's 2 years later, and I think Tim picked up on it, and the world has changed, or our perception of the world has changed radically in those 2 years, and has brought a kind of a sense of seriousness to what potentially was a rather light-hearted question originally. And I think so. Some of these presentations and the answers that we tried to offer have suddenly become really pressing and really important.
Very much agree there. Yeah,
I would agree with just a small point on the maths. I mean, I agree with what Martin and Margaret have both said. But where we're seeing it increasingly valuable is perhaps in the ability to program and code, which are really important, I think. And we're fortunate that more and more people can do this. And actually, to solve these problems, we're going to have to make things that are more complicated to design and more complicated to build, because using less material is hard. And doing that means that doing that economically, like what we learned on the sculpture, is that you have to script and you have to program the process and you have to design the design process to allow you to use less. And that's only coming through scripting and through enough maths to make Grasshopper or Python or whatever you're doing it in work. So they are really important, but probably not for, working out stresses, Mohr's circle of stress, or whatever I learned at university. I think the most advanced bit of maths I did was working out the gradient on a bridge I built in Dublin. A bit of differentiation.
I think coming back to your point, Tim, I think you're right, and especially in a world which you can see coming, where we're not building new stuff. If we're building new, what we're doing is taking a beam from one building and another leftover column from another building and starting to reuse the component parts. If you're doing that, then you need the kind of scripting that you're talking about. If you know I've got 5 beams of this size and 10 columns of that size of this length, then to do that efficiently is going to need a lot of computer power. So yes, I would never say that the maths is not important, but it's only
I think it's
for some of us.
I think it is, and I think its importance is emerging away from what we were all taught at university, into sort of figuring out how you sort things like that, or how you solve lots of data problems. So it's super interesting.
I think there's an interesting thing with this discussion, though, in that quite often there's an implied assumption that it's a zero-sum game. In order to be better at the other things, we have to get worse at maths, or if you're good at maths, you're bad at communicating. And I don't think that has to be true. Being better at maths is better. Being better at communicating is better. And you don't have to not learn maths in order to learn how to communicate. And that's the challenge for universities. It's not to say dumb down your maths in order to get better at something else. It's a different challenge.
Yeah.
It's all very interesting, and having to balance people's skills and taking on the industry and what the skill set is needed in the industry. We've got another question from David Brett, coming in to say that, structural engineers rarely feature on TV, radio, and national media. Have you got any ideas on what IABSE or what the wider industry should do about that? Because, I definitely know that I don't see civil engineers every day on the BBC, and so maybe people don't know what they're doing behind the scenes.
As the architect on the call, can I answer that?
Yeah, go for it.
Because obviously it's the architects who are trained to present, and engineers never get the opportunity. I think it's a misnomer. I think we should all be talking about design. And one of the things that is critical nowadays, and unfortunately the recent change at the top of government doesn't seem to have made any difference, that people are still talking in terms of construction and beauty rather than construction and climate. Now that is something that engineers and architects should be very well versed to talk about. But to talk about construction in such superficial terms is really sort of facile. There's no reason why engineers should not be putting themselves forward and to be the spokespeople for what actually is a really, in large part, a very strong technical area. And as Nick mentioned earlier, the presentation that Rachel Skinner, the current president of the ICE, gave this morning, with a really fabulous panel on the state of the nation and specifically on climate change, is evidence, if any was needed, that as construction professionals, it doesn't matter what our badge is. We simply need access to platforms to make this get this communication out there.
Yeah. I think there's something interesting as well about engineers' reticence to ever be wrong, and exactly what Margaret was saying about how we need to know our numbers. And I think every engineer is always paranoid of being proven wrong by another engineer, and they'd much rather say nothing than risk being contradicted. And I think that's got to change. When we're talking about right and wrong, we need to speak up. But we treat everything as a maths test where there's a correct answer, and if we're not certain of the correct answer, we keep our mouth shut.
Yeah, I think we need to be bolder, but we also need to encourage each other. I think, knowing that we are bad at these things, we need to be, even if you get something wrong, to have somebody ring you afterwards and go, "Oh mate, it doesn't matter. You still got up there. Well done. You still had the courage to go on Radio 4, or go on the BBC and say anything. You know, I think we're too ready to criticise, and we're too ready to be too precise and sort of say, oh, well, that one tiny point was not perfect. So being a little bit kinder to ourselves and I think each other, if we want to be heard, we do need to bolster each other a bit.
I think we need to embrace failure. I mean, Martin's been to a special club that's run by the engineering club called Up Club, which has only happened twice, but on both occasions has been absolutely fantastic for a group of engineers coming together and talking about their worst mistakes and learning from each other over lots of dinner and wine. And you know, by doing more of that and embracing sort of failure, I think, well, it's not failure, it's kind of success if you learn from it, isn't it? And don't do it again. So,
Definitely.
Well, engineering as a profession has historically always made the greatest strides from coming out of failure, whether that was bridge collapses or whatever else. The problem we have now is that I think the failure that we're having to learn from is one that's of our own making and that we're right in the middle of. It's all around us, and I think we've slightly been guilty of being the frog in the boiling pan. And we're only now becoming really aware of that. So I think there is going back to the original point, there is always this perception that engineers are not good communicators and they don't grasp the microphone, they don't get the big fat pen. I don't think that's true. And I think it's if that gets perpetuated, then it cowers people to take the stand. And I think that everyone should have the opportunity, and it doesn't have to be on television. It can be in a conversation in the pub, or it can be a presentation of school kids. It can happen on a daily basis at the smallest possible level. But so long as everyone is having the same discussion with the same urgency, then actually I think we're probably doing the right thing.
Mm-hmm.
Well, I'll go on to the next bit, that kind of links on. So I'm assuming you're talking about the climate change crisis here, Martin, that's all around us. And we've got a question. Are the stories that we're telling now different from 20 years ago due to climate change? And how have they been kind of adapted?
The basic import of telling stories, I think, is remained constant. How we go about communicating stories, I think, is changing. And historically, we have been sort of concerned with or in recent years, we've become more and more concerned with technical data and how we communicate that. And I think several of the presentations this evening have picked up on the benefit of stepping back and asking very basic questions: why and who are these projects for? Rather than leaping into the technical part of it. So I think the underlying need for storytelling remains as strong as ever.
That makes sense. Yeah.
Can I just add something on that? I think the stories are easy when there's a goodie and a baddie, and it's really nice to have a clear narrative. And climate change doesn't fit that because the baddie is abstract. It would be ever so easy if, the baddie was, a person or a monster from Mars. But I think that is why the stories now are extra important to galvanize that common understanding, almost back to that post-conventional idea of, what is our morality? What is the basis for what we do? And I think that story is coming, but it isn't quite there. It's not like the Manhattan Project. We're like, we need to build this today. If not, we're all dead. That story hasn't quite landed, I don't think. But
no, I think we've got one more to wrap up with. And this is kind of directed to you again, Nick. Do you think that your post-conventional moral framework is emerging naturally, or do we as engineers need to do something more to get an answer?
So it does always emerge. it does emerge naturally is the answer, is that in that it will always exist, and if we don't fill it, the void is filled. If we do nothing, the existing moral framework remains. We have a moral framework in place. If we want to change the moral framework, then we have to actively change it. And that post-conventional thinking of defining what is our purpose, and back to Martin's point of the why, we could quite easily go and build bridges without ever asking why. And the chances are there might be some pretty shonky bridges that aren't doing much good. But that's the same thing, I think, as the moral basis. And we need to question what is the moral basis for what we do. And we must then define all our behavior to align with that moral basis. So it will be filled if we don't fill it. I'll hand over though, see what other people think.
Anyone else have any views on that one?
I guess as much as anything, it's a question of speed of change, isn't it? And coming back to Nick's point about slavery, and eventually it got there, but we haven't got 70 years to sort out a climate crisis. We know we've only got 30 really at tops, but before we're really building absolutely nothing. And, an awful lot of other stuff has to change in the meantime as well. So I think the storytelling has to come it has to happen, because you have to get a pace of change which isn't a general, normal, slow cultural shift. We haven't got time for that.
I think it needs to become personal as well. So rather than we all need to do this, what do you yourself need to do? How do you shift from egocentric view of the world to an ecocentric view? And how do you change your own behaviour every day? Is really important, because it's such a sort of nebulous, huge worldwide problem with us all implicated. Actually, I think there must be a sort of John F. Kennedy quote in there: "Ask yourself what you'll do for your country," or whatever. But by personalising it to our own behaviour is really necessary, I think.
And particularly as practicing engineers, because we know that we specify more carbon in a week than we do when we spend in a year for our own personal lives. So, have a professional duty which goes way beyond. It's not instead of the personal duty as well, but as a professional duty, we absolutely have a duty.
Yeah, I mean, we're utterly gifted in the power we have, really. I mean, more than almost any other profession, I think.
Yeah.
There was a very good point raised by Oliver Broadbent recently, that as professionals in this sphere, we have sort of three levels that we can influence. The first is obviously to act and to design more thoughtfully with respect to carbon. The second is to advise clients in particular, but anyone who'll listen. And the third is to advocate for improvements. And so I think if we look across all those opportunities, that should be something that fills the front and center of our daily working lives, which sort of picks up on the first of 6 points that were raised in the ICE presentation earlier today, which is this is a climate emergency. Treat it as such. Treat it as an emergency. Otherwise, it really will be a short story.
No, that makes sense. So I think we're going to have to bring it to kind of a conclusion here. I'd like to thank all of you for coming along and giving you another go at your presentations, and really giving us an idea of what the Henderson 2019 looked like and the discussions that we brought into it. Now, tomorrow or the next day, you should all everyone who's attended will receive an email from the ICE Director, hopefully with some links that will pass you through to some of the Henderson Colloquium documents if you want to see a kind of larger summary document from the event, and other Hendersons in previous years, if this has got your mind whirring. We also have several events coming up through the British IABSE Group. There's a study tour to Belgium in 2022, and there's a Mill Medal lecture next month. We also have a Nethercott Prize, which has a deadline of the 15th of October to enter. So if you want to get on that, you've got 10 days to go. So just go through the links on the website and you'll get details there. So that leaves me to say thank you all for coming, and I hope all of you who have attended have enjoyed the presentation, and I wish you all a good evening. Take care.